Okay, so a proton moves in a circular path in a region of uniform magnetic field. Notice that B is into the page. Is into the page, right? Okay, now they want you to label the velocity vector V of the proton, right? The velocity is either, it's tangential, right? So it's either that way or it's this way. Okay, now what you need to do, so it's this way or this way, right? So what you need to do is figure out which way it has to go. If it's going this way, it would be going clockwise, this way, anti-clockwise, right? But only in one of these directions is the force. You want to do your little right-hand rule. You want to generate a force toward the center, okay? And the force must be toward the center of the circle, right? That's the way a centripetal force works, is we have to pull the object toward the center. So you figure out which way the velocity's got to be. I know the force has got to be toward the center, okay? All right. The speed of the proton is 2.16 times 10 to the 6 meters per second. The magnetic field is 0.042 teslas. For this proton, determine in meters the radius of the circular path. Give your answer to an appropriate number of sig figs. Now we have 3 there, 2 there. So we should have 2 sig figs, right? Okay. All right. 3 marks. Okay, yeah. So one of the marks is actually for the sig figs. Okay, and then this is one of these QVB. Is mv squared, so the magnetic force equals the centripetal force. Okay, look up the mass of a proton. Don't confuse it with an electron. The charge of the proton is the elementary charge. So that's E, yeah, there you go. You'll get an answer that's between 0.5 and 1 meter. Okay, and then calculate in seconds the time for one revolution. Well, boy, it's going real fast, so it's not going to take long to go around. The period is going to be, by the way, the circumference divided by the velocity, right? So you've got the velocity there, right? So that makes sense, right? Distance divided by velocity will give you time. It's not very much time, okay? It goes around nearly 1 million times every second, 500,000 times every second or something like that. It's on the order of microseconds, okay? Which is interesting because if the proton really is going around, this is a random rant, right? If it's going around in a circle 1 million times a second, right? It's a megahertz radio broadcaster. It's sending off electromagnetic waves. Here's why. In one instant, the positive charge is there. In the next instant, it's here. Well, that means that there's an electric field around this, and in that instant, in that half a microsecond or 2 microseconds or whatever that it takes to get from here to here, roughly, it's about 2 microseconds, a little less. Okay, this electric field collapses. Well, a collapsing electric field is like a current, so it generates a magnetic field, which makes an electric field, which makes a magnetic field. This thing is a radio transmitter. And this, the radiation it gives off is called cyclotron radiation. That means that an orbiting proton like that slowly loses energy and I guess spirals in. Is that right? Yeah, I think it does. Anyway, all right.